Welcome to This Explainer. Today, we're going to stretch our imaginations far beyond Earth's comfortable water-based biology. We spend so much time looking for life in the universe that looks exactly like us. But what if the cosmos actually uses a completely different set of blueprints? Prepare to absolutely rethink what it means to be alive.
Okay, let's dive right into this by contrasting our world with an absolute cosmic extreme. Earth's magnetic field sits at a gentle 0.5 Gauss. It's basically an invisible shield that's barely strong enough to move a pocket compass needle. But a magnetar? That's a hypermagnetized dead star boasting a magnetic field of 1 quadrillion Gauss. If you brought a magnetar within 1,000 kilometers of Earth, it wouldn't just wipe your credit cards. It would literally dissolve the electron shells of your body's atoms and instantly tear your entire molecular structure apart. No way you're surviving that.
So standard chemistry, the delicate structures of DNA and water, none of that can exist here. It is a completely hostile environment for organic life as we know it. But that brings us to a really fascinating thought experiment. What if this terrifyingly extreme, atom-crushing environment is actually the absolute perfect recipe for a bizarre alien biology? What if life doesn't survive in spite of this magnetic field, but precisely because of it?
To understand how this could even be possible, let's quickly anchor ourselves with the basics. A magnetar is a type of neutron star, which is the collapsed core of a massive star that died in a supernova. Imagine taking a mass greater than our entire sun and squishing it down into a sphere that's only about 20 kilometers wide. That's roughly the size of a small city.
Because all of that mass is packed into such a tiny, tiny space, the surface gravity is absolutely staggering. We're talking 100 billion times stronger than what we feel here on Earth. Just to put that into perspective, if you were to drop a standard fluffy marshmallow onto the surface of a neutron star, the impact of that tiny piece of candy would release as much energy as a tactical nuclear weapon. It's literally an environment of ultimate extremes. Now, what's really interesting is what happens at the microscopic level under these conditions, because it's truly bizarre. On Earth, our atoms are roughly spherical, thanks to electrostatic forces. But when you cross the threshold of 1 billion Gauss on a magnetar, those normal atomic bonds are completely overpowered. Electrons are forced into what quantum physicists call Landau states. They can no longer roam around in free, spherical clouds. Instead, they're forced into impossibly tight, circular orbits. And the result? The atoms themselves are violently squeezed from spheres into long, narrow needles. And that structural change completely rewrites the rules of chemistry. These distorted, needle-shaped atoms abandon standard three-dimensional organic chemistry for something entirely new, which we can call magnetic chemistry. First, these atomic needles effortlessly align parallel to the incredibly strong magnetic field. Second, because their electrons are so restricted, they actually begin sharing them tip to tip. And finally, this allows atoms in the star's hot atmosphere to fuse into ultra-strong, highly conductive, one-dimensional metallic polymer chains.
Which brings us to Scenario 1, a visionary concept popularized back in 1980 by the physicist and science fiction author Robert L. Ford. He theorized that if these complex polymer chains could form along magnetic field lines, they could potentially store information, carry electrical currents, and even undergo metabolic reactions. This gives rise to a wild possibility. Atomic-scale filamentous beings. We're talking about organisms that could theoretically evolve directly within the star's hot, incredibly magnetized outer crust.
Let's look a bit closer at the biology of these theoretical creatures. Because they're made of one-dimensional atomic polymer fibers, they'd be flat, ribbon-like, or thread-like structures. Movement for them would be highly directional. They could glide effortlessly parallel to the magnetic lines, kind of like trains on a track. But moving sideways across the field lines, that would require immense energy to break the quantum flux lines. And instead of our slow chemical neurotransmitters, their nervous systems would fire electrical impulses at near the speed of light along conductive chains. They would function as a living, thinking tapestry woven directly into the magnetic fabric of the star, feeding right off the thermal heat of the core. But wait, what happens if we plunge even further down, beneath the outer crust? Well, down here in the inner crust in the core, the pressure is so unthinkably immense that even our needle-shaped atoms are completely crushed out of existence. Protons and electrons are forcibly fused together to create a dense soup of pure neutrons. We have officially entered the realm of nuclear degenerate matter. Down here, electromagnetism is no longer the boss. It's totally replaced by the strong nuclear force. Think about it. Earth life relies on chemical bonds driven by electrostatic forces, with reactions taking milliseconds. But life deep in a neutron star? That would rely on nuclear bonds driven by the strong force, reacting in picoseconds. That's trillions of a second. It is a staggering, blistering leap in speed.
This introduces our second form of theoretical life, which Robert L. Forward called the chela. Unlike the filamentous beings up on the surface, the chela wouldn't be made of atoms at all. They would be constructed entirely out of unimaginably dense nuclear matter.
To really grasp how dense this nuclear matter is, just consider this number for a second. If you had a chela organism that was the size of a single tiny sesame seed, it would weigh 70 kilograms. That tiny speck would weigh as much as a fully grown adult human. Because of this, they'd likely be flat, poly-like creatures forced low to the ground just to survive the crushing gravitational pull.
But honestly, the physical density isn't even the most mind-bending part. It's the speed. Because their biology is governed by nuclear reactions rather than slow chemical ones, their metabolism operates almost 1,000,000 times faster than ours. For a nuclear-scale creature, a single thought, a heartbeat, and an entire generation would occur in the literal blink of a human eye.
Let's break down the math a bit to show just how vast this asymmetry of time really is. To us, 1 second is just a fleeting moment. But to a neutron star organism, that single second translates to roughly 11 days of experience. If a human astronaut took an hour for a lunch break, an entire alien civilization could evolve from simple toolmakers to a spacefaring society. And an 80-year human lifetime, that equates to 80 million years of history for them. That is just wild.
Now you might be wondering, wait, doesn't intense gravity slow down time according to Einstein? And you'd be totally right. The massive gravity of the neutron star absolutely dilates time, slowing it by about 20 to 30% relative to deep space. But their nuclear chemistry speeds their internal clocks up by a factor of 1 million, so the biological chemistry wins the race by an absolute landslide.
Which leads us directly into this tragic yet incredibly fascinating situation, the first contact paradox. Imagine a slow-moving human expedition arriving in orbit around Magnetar, detecting structured emissions and trying to say hello to this hyperfast society on the surface. How in the world do you communicate when your clocks are fundamentally out of sync?
Let's look at this agonizing perspective flip. It takes a human astronaut just 5 seconds to broadcast the message, "We come in peace." In second 1, the human hits transmit, and the aliens detect a low hum. By second 2, the human is just waiting for the message to send. But on the surface, the alien scientists who heard the first hum have lived out their entire careers and retired. By second 4, multiple alien generations have lived and died. By the time the 5-second transmission finally ends, the alien society has progressed into an entirely new technological era.
And what happens when they reply? Well, operating at nuclear speeds, the aliens could theoretically shoot back a response containing the entire encyclopedia of their species, their grand history, and all their scientific breakthroughs. But because they operate so incredibly fast, the entire transmission would be over in a fraction of a millisecond, way before our clunky, slow human instruments even knew it had started.
This forces us to ask a really compelling question about the data we see today. Astronomers constantly observe massive energy bursts, known as starquakes, unexplained glitches in pulsar spin rates, and microscopic gamma radiation flares. We log these as natural background noise or cosmic anomalies. But could these tiny variations actually be the exhaust, the industrial activity, or the communication bursts of a hyperfast civilization operating right under our noses?
So the absolute crucial takeaway here is that we have to rethink our parameters. We have to stop strictly looking for carbon, liquid water, and comfortable temperatures to find life in the vast darkness of space. The traditional Goldilocks zone is just far too narrow if the underlying physics of the universe allows matter to organize in such wildly different ways.
Ultimately, it comes down to this core idea: life is not defined by its ingredients, it's defined by its organization. At its heart, life is simply a process. It's a system that resists entropy, gathers energy, and stores information in complex physical structures. It really doesn't matter if the canvas is made of watery cells on Earth or ultra-dense nuclear degenerate matter on a magnetar.
I want to leave you with this final thought to ponder. The next time you look up at the night sky, realize that the universe might not be a quiet, empty desert waiting for liquid water. It might actually be teeming with life, hiding in the most extreme, terrifying environments imaginable. Could entire galactic histories, scientific revolutions, and golden ages be lived, celebrated, and lost in the exact time it takes you to take a single breath?
Please like and subscribe.